welcome you all for the short video lecture series. So in this video lecture series we will discuss and try to understand the few example problems related with corona as well as sag, right? The first thing we will start from the corona part. The question is, a three-phase line has a conductors 2 cm in diameter spaced equilaterally 1 meter apart. To understand this first line, you need to imagine a picture like this: three conductors with 2 cm in dia, and now the distance between these three things, these three distances are equal, which you may consider as d, and here the d is equal to 1 meter. If the dielectric strength of the air is 30 kilovolt per centimeter, that is your G0 is 30 kilovolt per centimeter maximum, but when you substitute in the equation, you need to substitute the RMS quantity, and the RMS is nothing but 21.2 kilovolt RMS quantity, right? And next, find the disruptive critical voltage for the line. First thing you need to calculate disruptive critical voltage is nothing but VC expression. Take the air density factor del is equivalent to 0.952. So if it is 1 means normal condition. If 0.952 means there are some rainy effects or stormy effects. That's why your critical descriptive voltage gets reduces, and because of this factor, density factor, and irregularity factor is M0 is equal to 0.9. If it is 1, it means that it is a uniform conductor. If it is 0.9, it is an irregular conductor. Now you are just substituting all those things in this dielectric strength of equation. Disruptive critical voltage Vc is equal to M0 is nothing but 0.9, G0 is 21.2 RMS, and del is something 0.952, and d by r, the distance between the conductor is 1 meter, and conductor radius is 1 centimeter. Conductors 2 centimeter in diameter, equally spaced, right? Now the given conductor diameter is 2 centimeter, and that's why the radius of the conductor is 2 by 2, it is 1 centimeter, and the 100 divided by 1 log E 100 divided by 1 will give the log of d by r. And now when you solve all those things, the voltage is 83.64 kV per phase, and which is the RMS quantity of per phase quantity. Now if you convert into line quantity, you need to multiply by √3, and multiplied by 83.64 will give the 144.8 kV, right? This is the first example. And second example, you can take this example, a 132 kilovolt line with 1.956 centimeter dia conductor is built so that corona takes place if the line voltage exceeds 210 kilovolt RMS, right? If the value of the potential gradient at which ionization occurs can be taken as 30 kilovolt, that is inga kodutha G0 irukku, G0 is 30 kilowatt per centimeter. Find the spacing between the conductors, right? So assume that it is a three-phase line and conductor radius is this much, 1.96562 divided by 2 will give this much centimeter, and dielectric strength is RMS quantity is 21.2 kilovolt, and disruptive voltage per phase, and this dielectric strength may be can be asked as an multiple choice question, right? What was the dielectric strength of the air at the normal temperature and mercury pressure, and I will give this as an answer, right? So disruptive voltage per phase Vc is equal to 210 by √3, which is this much voltage. So this 210 is the RMS quantity. And now assume smooth conductor, that is your irregularity factor as M is equal to 1, and the standard pressure, so del is also becomes 1. Now your Vc is equal to G naught into R into log of E d by R. This is M del and M naught both becomes 1. So del G naught is equal to 21.2 and R is 0.978 log of d by R. So distance we don't know, that is you need to find out, divided by R, and log of d by R is nothing but the same expression. You can find it as d by R is equal to this much. Now log of d by R is nothing but this much, and you know the R value of now based on this log E d by R is equal to 5.848. You can calculate the d by R, that is 348.8, and conductor spacing is D is equal to 348 into R, and R you already know that 0.978, and so that 347 centimeter is the distance between the conductor to satisfy the conditions, right? So next example is with respect to the sag, right? So here a 132 kilovolt transmission line has the following data, that is weight of the conductor is 680 kg per kilometer, length of the span is 260 meters, ultimate strength is 3100 kg, and safety factor is 2. Calculate the height above the ground at which the conductor should be supported, right? So ground clearance required is 10 meters. So now weight of the conductor per meter run is nothing but 680 kg per kilometer. Now we are converting into per meter, that is 0.68 kg. Working tension is ultimate strength divided by safety factor, this we already know, and our working ultimate strength is 3100 divided by 2, 1550 kg. Span length is L is equal to 260 meters. So sag is equal to the formula, basic formula you already know. Please refer the your previous short video lecture on the sags. So W into L square divided by 8 into T. W is the 0.68 kg, L is the 260 meter square, and 8 into 1550, which is nothing but 3.7 meter. So now this sag is nothing but 3.7 meter. So what is mean by sag? Sag is the distance between the topmost conductor point and lowermost conductor point. So now conductor should be supported at the height of 10 plus 3.7. For example, if a conductor, one conductor is here, the other conductor is here, the distance between these 2 points you can consider as sag, right? So now question is, from the above the ground, what is the tower height you require to make this setup? So that means this is your 3.7. You need a ground clearance of 10 meter. So now you need a total of 10 plus 3.7, 13.7 meters. So this is the very basic example on the sag. So next example is a transmission line has the span of 150 meter between the level supports. Span of 150 meters between the level of supports. The conductor has a cross-sectional area of 2 centimeter square. The tension in the conductor is 2000 kg. Tension means this working tension is 2000 kg. If the specific gravity of the conductor material is 9.9 gram per centimeter cube and wind pressure is 1.5 kg per meter length, calculate the sag. What is the vertical sag? So here wind pressure is included. So from the questions you identify the following data. Span length is L is equal to 150 meters and working tension T is equal to 2000 kg. Wind force per meter length in terms of kg, WW is equal to 1.5 kg. So weight of the conductor per meter length is equal to W is equal to specific gravity into volume of 1 meter conductor. specific gravity given here is 9.9 gram per centimeter cube. That means ஒரு சென்டிமீட்டர் கியூப்ல 9.9 கிராம் வெயிட் இருக்குன்னு அர்த்தம் மீனிங். ஸோ 9.9 into 2 into 100 is equal to 1980 grams. That is nothing but 1.98 kg. Right? The total weight of the 1 meter length of the conductor is equal to W square plus WW square, which is nothing but 2.48 kg. So now sag is equal to total weight L square divided by 80. Total weight is this one. Length between the two conductors 150 square divided by 3.48 meter. This is the value of the slant sag in a direction making an angle theta with a vertical, with reference to the vertical. So referring this figure, your gravity weight, that is your conductor weight, will be on this direction. Your wind velocity will be on this direction. So the resultant weight will act on this particular direction. So you need to find out the particular angle theta. Tan theta is equal to your opposite by adjacent side. WW divided by here, this opposite divided by adjacent W will give this 0.76. Theta is equal to 37.14 degrees, right? So now the vertical sag is S into cos theta. So this 3.48 multiplied by cos theta, it is 2.77 meters. So this is the another example to understand the, one more example to understand the sag. Here the transmission line has a span of 275 meter. That is L is the 275 meter between the level supports. The conductor has an effective diameter of 1.96 centimeter and weights of 0.865 kg per meter. The ultimate strength is 860. So a factor of sector வேணும் நமக்கு. If the conductor has ice coating of radius thickness 1.25 centimeter and is subjected to the wind pressure of 3.9 gram per centimeter square of the projected area, calculate the sag for a safety factor of 2. Weight of ice is 1 cubic centimeter of ice is 0.91 centimeter. So இதில் வேற ஒன்றும் இல்லை எக்ஸாம்பிளில். In addition to the previous problem, here they have included the ice weight. So you just go through this worked example, you find the value of sag something, right? So you just work it on this particular example. So with this we can wind up your third unit, that is your mechanical design of the transmission line. So thanks for watching. Thank you.